Right coset decomposition of a group. Suppose H is a subgroup of a group G. Every right coset of H in G is non-empty. Any two right cosets of H in G are either disjoint or identical. The union of all right cosets of H in G is equal to G. Therefore, the set of all right cosets of H in G gives us a partition of G. This partition is called the right coset decomposition of G with respect to the subgroup H. To get distinct members of this partition, we should proceed as follows. First of all, H itself is a right coset. If there is an element A belongs to G such that A does not belong to H, then HA will be another distinct right coset. Again, if there is an element B belongs to G such that B does not belong to H and also B does not belong to HA, then HB will be another distinct right coset. Proceeding in this way, we can get all distinct right cosets of H in G. Then we shall have G is equal to H union HA union HB union HC where A, B, C are elements of G. So, chosen that all right cosets are distinct. That is, G is the union of all right cosets of H in G. Similarly, we can also get left coset decomposition of G. Theorem: if H is a subgroup of G, there is a 1-to-1 correspondence between any two right cosets of H in G. Proof: let A B belongs to G, then HA and HB are any two right cosets of H in G. Let F is a mapping from HA to HB be defined by f of HA is equal to HB for all H belongs to H. Now we show that F is 1, 1 and 1, 2. F is 1, 1. If H1, H2 belong to H, then H1A, H2A belong to HA. So, by definition of F, we have f of H1A is equal to H1B and f of H2A is equal to H2B. Now, f of H1A is equal to f of H2A implies that H1B is equal to H2B, since f of H1A is equal to H1B and f of H2A is equal to H2B implies that H1 is equal to H2 by right cancellation law in G, implies that H1A is equal to H2A. So, F is 1, 1. Since only equal elements of HA can have the same image in HB. F is 1, 2. Let H dash B be any arbitrary element of HB. Then H dash B belongs to HB implies that H dash belongs to H implies that H dash A belongs to HA. Now, f of H dash A is equal to H dash B by definition of F. Thus, H dash B belongs to HB implies that there exists H dash A belongs to HA such that f of h dash a is equal to h dash b. Therefore, f is onto. This proves the result that there is a one-to-one correspondence between any two right cosets of H in G. Index of a subgroup in G. Index of a subgroup in a group. If H is a subgroup of a group G, then the number of distinct right or left cosets of H in G is called the index of H in G and is denoted by G colon H inside the square bracket or by I G H.